Okay, checking out the Fantom 13.5 turn motor, the 19480S, which is the M spec one, which is the not the short stack one, which is an RS. I'm going to check it out for boosted performance. Now, how I'm going to do this, I'm going to run it at set it up at 30 degrees. And then I'm going to run it up on the dyno with the weight for accelerating, and then I'm going to analyze the results on the computer and get a graph like this, which is maximum power, maximum efficiency, etc. And then I'm going to try and repeat the result with 45 degrees advance, and then if I can get up, say, 60 degrees advance, but the dyno doesn't like too many revs. But anyway, we can analyze the results on here and try and work out where the best revs are for switching your boost on in the speed control. For instance, what the first boost goes, and then the turbo boost at top end. See if we can get any useful results to help you gear the motor. I record all the results on a sheet like this, like I normally do with all the figures, and also making sure that everything is running at the same voltage, 8.4 volts on the battery, so that the dyno results are as close to comparable every time I run it as possible. So at the moment I've set this to 30 degrees. Sensor board's not too bad. Get the results off this, then run it on the dyno. Okay, at 30 degrees M-bell timing, we've got on the 13.5 got a kV of 3168 and only 2.2 amps. So and put it on the dyno next. Right, the dyno test. Going to record some of the useful data from here. It's recorded on the record number 1. All these figures are have been sent down to the computer. I'll just record that now there, and it's this one here comes up as this file. I'll rename it, and then I'll import it and work out the graph. I've transferred all the data that came up on the dyno to the computer. For instance, the maximum horsepower 203 watts. At that point the efficiency is 56.9%, and it's drawing about 54 amps at that point, and it's reached that point in 0.16 of a second, and the revs is 10,200. The torque's 190 at that point, and also the maximum efficiency reached in 0.32 of a second was 17,500, and it was generating that torque, and the efficiency at that point is well over 90%. One other figure worth looking at is top RPM 25,300 at 8 volts will give you kV, and the endpoint 3.2 amps. So all those figures I've transferred to the computer. Now it's not 100% possible to get the figures dead right. I've recorded all the figures on the piece of paper. As I said, the kV, when I measured it on the motor analyzer, it came at 3168. On this one it comes out at kV 25300, 8 volts, 3163, so that's pretty close. Now looking at the max power was 190 watts. Is that right? 190 watts? No, that's the torque. Max power 203 watts. The torque was 190, and it was at 10,200. Looking on the graph for the motor at 30 degrees, we've got 203 watts at 10.5, which is close enough. No load 25,000, close. Now the peak efficiency, it's pretty flat, the top of the efficiency, so it's slightly out. It's got a higher point, 94%, though it's close. We had 92.8%, but at 17,500. You can see on the max power, the amps, the efficiency was 56.9, and the amps was 54.5. Well, if I go to the this graph, you can see now for the same we've got the same motor. You've got 202.8 watts, and at that point you've got the torque 180. So we got it pretty close. Torque was 190, so it's a little bit out. Current 53 amps. We had 54.5. The only thing that's out is the efficiency, but at 10.5 it says 52.5. Yeah, 54. No, not where's the efficiency? 56.9. Time isn't shown on this graph, but I've kept the figures. 0.32 to that point, it was a second, and 0.16 to this point. Anyway, how does what use is all that? Well, it shows you that with this motor, when you get to this point here, maximum power, you should then switch in your first time in advance on the speed control, the boost. So you want it to come in when you hit maximum power of about 10,000 RPM. If you switch it in earlier, you'll miss the peak power point. And then we're going to boost it up until you hit the maximum efficiency point. So I'm going to draw another graph for say you put on 15 degrees of initial timing boost, taking that up to 45 altogether. I'll do a graph with 45 degrees, and then when you hit top, when you push the stick fully forward, you get a turbo boost, and you can add say another 15 degrees then, or whatever. Anyway, that is the graph analysis, and it's pretty close to what we got on the dyno. And I'll show you later, we can compare motors as well. But oh yeah, just you got the kV and the amps all matching. The only thing that didn't quite match was the maximum efficiency point. It's very flat there, so everything else is good. I've reset the motor to 45 degrees. And at 45 degrees it's now doing a kV of 3827, 5.2 amps, and 29,000 RPM. Right, battery's fully charged. Got the motor with the 45 degrees advance. Here we go. Okay, it got up to maximum RPM, 30,000 RPM very quickly. So just check the results, see if they're much use. Okay, let's have a look. Reached 30,000 when it shut off. We got the maximum power, 224, which you can see reached 0.2 of a second now. and it was 13,000 RPM when it was doing 165 torque. The efficiency at that point was good. Sometimes the efficiency is slightly out the amps, and the peak efficiency 1.08 seconds. It says 28,000, seems a bit high to me. 90%, 10.5 amps. So anyway, I'll transfer the figures to the computer. Let's just stop that, and then I can look at the results on the here. Be this one here, and I'll just rename it. There's the first one. This is a new one, and then I'll analyze it and put the graph up. Okay, here's the result of the 45-degree dyno test. The figures from the dyno show it's about 224 watts at 13,000 RPM, and the torque's about 165. We know the efficiency figure's not right on the dyno, especially at high revs. Anyway, it's come out as close as I can get it without spending too much time. 222 watts at 13,100 is close enough. And if you look at here, the watts, 222, the torque 162 at 48 amps, which is close enough. It was 48 amps and 165. Now, so what use is this? Well, if this is if you applied 15 degrees of electronic timing. So if we compare, I've got the 30 degree and the 45. The 30 is the blue one. Now the 45 degrees, you've got more power at a higher rev point, and so you get to 10,000 RPM, you bang on 15 degrees extra timing, and then you just let the motor rev up to the maximum efficiency point, which is over 20,000 RPM. When you hit this point here, the motor basically peaks out. So you then it's then running at, you go from about 10,000 RPM, boost it, you get 20,000 RPM, and then when you get to this point, basically you should apply your final boost, which is on your stick, and say give another 15 degrees to take it up to 60 degrees. About 64 they say is the maximum. It really should be more like 60. So I'll do that in a second if the dyno can show it, because the rev's going to be quite high, and you can see and then we'll get the final rev point where you should be running the motor at maximum speed. Will be at the maximum efficiency point. Okay, 6 is a bit too fast, so I've set it at 56 degrees time in, and that's, I think, it'd be enough for the dyno. Okay, we'll try it at this, otherwise the amps are going to be too high. This is already at 14.7 amps, KB5271, 36,000, over 36,000 revs. Right, just going to run the dyno up with the 56 degree timing on the Fantom 13.5. The battery's at full voltage. Let's see if it'll handle the current. Here we go. Well, it got the 30,000 RPM so quickly, I don't know how much data it would have recorded. So let's have a look. It's got some data. Let's view the record. Okay, there's the data there. We've got peaked out obviously at 30,000. Got got there really quickly. 30,100. Here's the efficiency figure. 7.2 volts, so we can work out the kV. And we've got the maximum horsepower 204 in 0.28. 15,400 was the maximum power point, and torque was 127. 65% efficiency, 47 amps, and we've got a couple of other figures, but it peaked out. So I'll just transfer these figures onto the onto here. Luckily, it's I just stop it. And there's the new file just popped up, so I'll just mark that up as 56 degrees and do the graph. Converting the dyno results for 56 degrees advance from the dyno to the graph. We had a kV of 5271 at 14.7 amps, which I've put in there. So this is the 56 degree version. The watts was 204.7 at 15,400. I've got it close, 207 at 15.4, and the torque and amps on here it's about 125 and 47 amps. It was 127 at 47 amps, so that's all close. Now the efficiency point to the right is always going to be slightly out because the dyno doesn't really go high enough on the revs. But you can see the efficiency has dropped off. It's only 73% now. And we can compare the results now. Compare motors. So here I've got the 30 degree, the 45 and the 56. That's blue, red, green. So looking at the power, blue, red, green, and the red one's got the most power, but the green one's got moved the power up the range about to 15,000. If I just check the point there, we can see about 15,000. And then maximum efficiency, though, when you're putting all your boost on, is going to be here, and you can see there's not much difference. The efficiency points, it's about that's 25,000 there, so it's about 22,000 RPM you'll be hitting. So if you, whatever the maximum speed is, you can work it out in your gear ratio. Current, it becomes very inefficient though. Look at when you've got 56 degrees advance on, it's drawing 27 amps, so it's going to get really hot if you're going to keep going at that sort of speed with that amount of advance. It's only for a last bit of burst of speed before you drop back, because the efficiency is way down as well. If you're going to run those revs at the first small amount of advance, it can't really pull it because you'll be way over the efficiency point coming down. Once you go over the top and come down again, the motor becomes inefficient and will heat up just as much as if you run it on this side of the efficiency curve. So that's your first switching point, the blue. Then you switch it at the red point. Doesn't take long to get from there to there, and that is where you run most of your car after the acceleration, and then your last burst of power is just on top, but very inefficient, that last bit. So that is the Fantom, and you can, well, I'll do another video how to work out the gear ratio.